This is Chapter 5.2, Finding Probabilities, Part 2, and I have a little special guest over here who may have some coughing going on. My granddaughter Sarah's helping me make the videos tonight, and she has a little cough, and so if you hear a cough, you'll just know that's Sarah. Anyway, this says a survey was conducted to measure the heights of U.S. men. In the survey, residents were grouped by age. In the 20 to 29 age group, the heights were normally distributed with a mean of 69.9 and a standard deviation of 3 inches. A study participant is randomly selected. The first one we want to know, a guy's height is less than 66 inches. So it's just like the one that I just showed you on the previous video. Since it's less than 66, you find the z-score first, 66 minus the mean, which is 69.9. And that's divided by 3, which is the standard deviation. You're going to get negative 1.3 over 3, and when you get that answer, I've forgotten what I got there, you're going to look it up in the normal distribution table 4, and you'll get 0.0968. Now here again, I would go to Tools for Success. I do Graphing Calculator in my Stat Lab, and go to Chapter 5, and we're trying to do normal distributions. And so when I did this, you would open this, and it's going to have 2 methods. I usually use the second method. I don't use this first method, and I'm going to blow it up so you can see it again. And when we pull this down, here's where you are. You're on second distribution. Select number 2, normal CDF. Excuse me. And from there, you'll see this on your table. And remember, that was negative infinity, but I use negative 10,000. If it's an upper bound, I use positive 10,000. So here we're going to go back to this, and that's how you would use the calculator. Now, if I'm doing in between 66 and 72, if you reviewed the other video, you subtract the 2, or I can go to the normal CDF, and you would put in your boundaries would be 66, comma 72, comma the mean is 69.9, comma 3 is the standard deviation. Then you just press enter and you have it. Here again, I worked 72 inches, more than 72 inches. I worked it by hand. Now this one's a little different. I actually should have subtracted 1 minus this, I think, because it's greater than. So this, I may have to correct this on the hand. Let me see if I can do that here. Oh, there, I did it. So it's 1 minus, I didn't realize I had put that on there. So 1 minus 0.7580 gives you this answer. What you would do first is find the z-score for the upper limit, and the probability would be 0.7580. The z-score is 0.7. That's what you look up on the table, or you could type in 72 is your lower bound, comma 10,000, which is your upper bound, and then 69.9, which is your mean, comma 3, which is your standard deviation. So if you go to second distribution, normal, CDF, that's what you would type in. This is one where 10,000 is your upper bound. So you'd have 72, comma 10,000, comma your mean, which is 69.9, comma, and then your standard deviation, which is 3. And then you would not have to subtract this 1 because you've set your boundaries. And then the last question said, can any of these events be considered unusual? The answer is no, because the events are not unusual. The z-scores are all between negative 2 and positive 2, and the probabilities are greater than 0.05, so I know then that they are not unusual.